so far, like cloud cost optimization, you are overspending by 70% or more. It doesn't take me to say it. It's Gartner says it, and it's a no-brainer. And as mentioned, we'll go through some of the typical hurdles into IT departments and showcase some best practices on how to tackle these. In the end, we want you to get as much bang for the buck. Right. The assumption is that you are already in one or more public clouds these days, and they bill you every single month. Now, let's try and break it down by personas working into an IT department. There will be someone working for finance or in conjunction with finance. Someone will be more onto operations, and someone else will be more of a pure dev, right? All of these personas have different problems. The finance people or people liaising with finance are frustrated because bills by AWS, GCP, Azure, Alibaba Cloud, you name it, are somewhat of a black box, right? You end up having hundreds of line items in your bills, which are mysterious to say the least. And you don't always know what exactly is going on with each of these line items and where do they come from and when do they come from. So you, as a finance guy or lady, end up paying the bill and being frustrated about it. Operations, on the other hand, have an entirely different problem. They need a budget to invest into very, very relevant things. These can be security, these can be scaling their infrastructure, these can be content delivery networks, whatever, you name it. Every year, the operations people talk to the finance people and struggle to get a little bit more of a budget, right? Um, Developers, finally, sometimes end up joining a company where the technical stack of choice was decided or chosen by others who may possibly have left the company. And so oftentimes dev people end up joining companies that work with legacy systems or even legacy infrastructure design. And well, they have to stick to it and they cannot uh, voice out their frustrations, like even bringing in enhancements, right? Everybody blames the other for some problems, like the devs blame the ops for the infrastructure, the ops blame finance for the budget, the available budget, and finance finally blames ops and devs because they don't give them a break with spending money in the cloud, right? Everybody in reality has a problem here. And the problem that everybody has here is that, um, uh, well, let's see, how can I turn on, all right. Yeah, finance needs granular visibility in the cost breakdown and reason, which business units, what environments, etc. Operations, like I said, they need a budget. Give them a budget, please. And finally, developers want to try out all of the coolest and latest things to streamline the operations much more and to make life easier. They don't need to necessarily keep working on the same tech stack for 15 years, right? Things change every day in the cloud. So, ladies and gentlemen, let me welcome you to what we call, or what the industry calls, FinOps. There's a ton of acronyms in the industry, ain't it? So let's try and break this big problem into pieces, right? Like I said, finance needs visibility. Once you have visibility, what you do is optimizations at the infrastructure level. That's mostly to do with ops people. And finally, application optimizations. This is with dev. You complete the first cycle, finance validates the savings, and then you rinse and repeat points number 2 and 3 under the supervision of number 1, right? So uh, let's look into it. Let's start by visibility. We'll then follow up with infrastructure and application optimizations. Before we do that, we assume that you as a customer or as a prospect already have migrated workloads in all relevant clouds to what, to stick with AWS terminology, we call spot instances or, well, low priority VMs. Similarly, if you have predictable workloads in the cloud, we assume that you've already purchased reserved instances to the purpose, right? Similarly, we assume that you've already right-sized, downsized underutilized EC2, RDS, and so many more instances. Similarly, we would assume that you already pay some attention to which kind of block storage tier to use for your files, whether they're hot, whether they're cold, whether they are infrequent access. One more, if you have resources that don't really need high availability, we would assume that you've already done a wise choice in terms of availability zones. And finally, I know it sounds like a no-brainer. Well, if you have machines which only need to work between 9 to 5, we would assume that you already have them running on schedule, right? If you haven't, however, well, there's luckily us to share some best practices with you. And here we start by looking at the issues finance people have with visibility into costs. We'll have 3 sections for each kind of optimization. So let's start by visibility and the business unit visibility level for finance, right? Um, Finance wants to see what the relationship is between costs and business unit. So I'm asking all of the finance people in here with us today, are you able to tell which business unit is generating which costs? Similarly, are you able to compare these costs by business unit from an historical standpoint? Like what were marketing costs for AWS last year, same point in time versus today? Are you able to even compare these with the budget that you make available for business units or not these days? Finally, what everybody in finance asks himself or herself, can I even enforce a budget on business unit? What happens then? And well, these are all worthy questions. The final one really leads us into an entirely different topic that's called cloud governance. It's worth a webinar on its own, so we won't delve into it today. But yeah, the short answer is yes, you can have this kind of visibility. Visibility goes down to an environment level. You as a finance guy, I mean, sure, this is probably not your bread and butter, but you want to ensure the cost for staging environments are lower than production. So are you able to tell whether staging costs are higher than production these days or not? Are you able to tell whether they are on par with the production costs these days? Are you even able to tell how many environments does your company have for, you know, ranging from staging to production environments? We've come across companies with 8 environments, and not necessarily 8 environments is the magic formula for really producing, bringing something from staging to production. Sometimes you don't really need that. But of course, if you don't know that, how can you even tell whether that's appropriate or not? Finally, why are there environments of a project we closed in 15? Well, and that's an evergreen, gentlemen and ladies. Especially as a company grows larger in size, people open up environments, start developing in them, then they leave the company or they're fired from the company. And if there's no cop ensuring these environments are closed down, well, these environments will very simply keep on lingering on and generating costs for you. You, as a finance guy or lady, want to know about it and take action on it. Finally, we get to the overall visibility. This is more high level. Questions like, are we unknowingly paying, double paying VAT on CloudX? You may not believe it, but this is a true story. And yeah, more often than not, there are companies spending unnecessary money moving and double paying VAT on bills where they shouldn't. But then again, bills are so mysterious that the finance people doesn't even know about that, right? Similarly, are you able to draw a trend of your spending based on services? Like say, storage costs have grown 30% versus computing costs have grown 3%. Are you able to do that? What does this very line item mean? Well, and that's a classic. Like I said, finance people aren't supposed to know everything about single line items when paying the bills, but it would be great if they could, because this way they could then liaise and do something about it. Finally, anomalies. Well, that's also important, because if something costs you a grand a month and then all of a sudden it generates 15K in 1 month, You want to be able to tackle that, to see what's going on there, and to even do a post-mortem analysis if that's over, of course. So that's with regards to visibility. There are ways to achieve this. Um, we will now instead start looking into the infrastructure optimizations for the ops. Well, I mean, many companies out there are working in DevOps modality already. I like distinguishing between more ops oriented people and more dev oriented people. It's hard to come by a 50-50 DevOps really. So when it comes to the infrastructure, we generally divide the main costs into three verticals: storage costs, computing costs, and well, networking costs. So let's start off by looking at the storage cost component. Um, Again, it should be a no-brainer, but selecting the appropriate storage tier and region for your storage is a best practice. You don't want to keep on hot storage and pay accordingly for assets which you only keep as like backups or stuff that you have to keep for legal reasons 10 years down the line. If you know you don't need to access those files, please choose an appropriate strategy for moving assets across storage tiers and products. You can automate this, you know that. Second of all, well, of course, add some secret GlobalDots sauce to it. You will see, we mentioned this several times. Um, there are technologies that we partner with, we position, and we master. And I would love to tell you about those. I can't. Of course, feel free to reach out afterwards to know some more about it. More in general, there are technologies that can make your life and builds easier and lightweight when it comes to storage costs. Moving on, enforcement of assets lifecycle policies. Well, yeah, I was talking about that before when talking about the appropriate storage tier. You can automate the assets lifecycle and say, look, anything that's older than 30 days, move it to infrequent access, and then 6 months down the line, move it to Glacier, right? You can even say everything that's older than 60 days, and in this environment, you know, just delete it after 60 days. We just don't need it. Why pay for it? Finally, versioning. Well, this is a cool one. I mean, everybody at AWS or any public cloud really would tell me it's a best practice to enable versioning. But the reality is not every environment needs versioning for, you know, when talking about block storage. Of course, some environments will, environments where you don't want to accidentally delete something and, you know, uh, but there are environments where stuff never changes, where there is no risk that someone will delete something. And so don't just stick to the best practice of enabling versioning everywhere. Just be wise when it comes to it, because versioning, in case you didn't know it, charges you for every version of every asset that you have in every bucket, right? Moving on to computing costs. Oh, well, this is a cool one. Like, computing costs generally represent up to 50% of your bill, sometimes even more. So then again, in case you didn't right size instances already, start doing it. And when I say right sizing instances, I mean kill idle instances that you don't need and scale down, like vertically speaking, those that are over provisioned. If your servers are running at 5% CPU all the time or are generating 50 kilobytes egress every day, what good chances are that these are over provisioned? Just shrink them and save money by doing this. It's no big deal, really. Of course, follow up by adding some secret GlobalDots sauce to it. And here again, there are technologies that really can help you shrink down computing costs. I won't mention them here. My invitation to you all is to please reach out afterwards so that we can tell you more about it. Third of all, select the appropriate purchasing plan for instances. And again, this is a no-brainer. Like, you don't, if you have a predictable workload and you know you will need this predictable workload for 5 years down the line, purchase it as reserved. Why pay on demand for that? Similarly, if you have machines like stateless workloads, which only shut on, process a job, and then shut down 30 minutes afterwards, why pay on demand rates for it? Go spot. For all the rest, sure, you can go on demand, or then again, you can contact us and look at alternatives in the market. Finally, think again what's better between managed and unmanaged. Now, you would expect me to tell you, move to unmanaged and save money by doing that, but that's not necessarily the case. All I'm trying to say here is no two customers are the same. So there may be customers using managed products, which of course cost more than unmanaged product, and having the whole IT team sitting idle all day in the office. Well, those people might want to reevaluate the product strategy and move to a managed, given that they have bandwidth. On the other hand, there may be people running unmanaged products, such as EC2 can be, and having, a host of IT people uh, working all day. So, you might free up some human resources by moving to managed products. And this is also cost optimization. I mean, the human cost is very, very valid factor in the equation. Finally, let's look at the networking costs optimization. Right, so CDN for egress where possible and reasonable. Like Steven said, we come from the CDN space. CDN is in our DNA. We could talk about CDNs for ages, for days, if you'd like. But what I'm trying to say here is, so if you have an S3 bucket or if you have a load balancer, right? Don't just egress into the public internet, or don't just egress into whatever third-party CDN you're using. Put a CDN in front of the load balancer or of the S3 bucket. What do I mean by that? We generally think that CDNs are there only to optimize performance. But the truth is that the price per gigabyte egress through a CDN, such as CloudFront can be on AWS, is much, much lower than plain egress from a load balancer or an S3 bucket. So even fronting this S3 bucket and a load balancer with a CloudFront distribution, even if it sits behind yet another CDNs, will slash off your costs by half. Think about it. Necessarily, you can't go without adding some secret GlobalDots sauce to it. And then again, we can help in many ways optimizing these costs for you. Reach out for more if you feel like it after the webinar. Um, Internal traffic routing versus external traffic routing. So this is a mistake I do very oftentimes. I always take for granted that prospects and customers out there already optimize this, and that the internal components of their infrastructure do talk through the private IP space. Well, guess what? This is not the case. And many prospects and customers out there, generate unnecessary networking costs by letting internal pieces of their architecture talk through the public IP interfaces. This is not good. This is not good from a performance standpoint, but this is especially not good from a cost standpoint, because, well, internal IP doesn't cost you anything. Public IP routing, on the other hand, does, and it does so sorely. So please look into it. And if you see any leak, yeah, go patch it, fix it, do something about it. Finally, if we look at people running hybrid clouds, you have a host of different options when it comes to connecting on-prem and cloud. So you can go direct connect, you can go interconnect, you can even go VPN tunnel, like from the cost list to the cheapest. Not necessarily the plan or the product you are sitting on right now is the right one, right? So what I'm trying to say with this point is, if you don't necessarily need a direct connect and you can do with an interconnect through a partner, just do that. It's going to save you big money. Similarly, if you're on direct connect or an interconnect, but we're not talking about, mission critical data flow, not so throughputing data flow, or data flow that only happens throughout some time windows, consider the possibility of downgrading that to VPN tunnels. I know it's not going to be as performant as a direct connect, but it is going to make a difference on your monthly bill. And having said that, I think we enter to the application optimizations, which I'll leave to Stephen, who is unmuted.
That's all right. I was muted. Yeah, application modernization. So this is the optimization for the devs. So this is really kind of the really technical, nitty gritty, getting under the hood stuff. And you know, a lot of the ways we people offer to save money, and you can save money, or Amazon will tell you how. I mean, will save money, or an off the shelf application will tell you how to save money. A lot of right sizing options there. It will tell you about underutilized CPU and blah blah blah. This is like the low hanging fruit, and then the more nitty gritty bits, and this is where sort of GlobalDots expertise of being veterans really comes in. Is these are things that possibly you wouldn't have thought of that can make a big difference later on. And there's a lot of these. It's not like a silver bullet where you go in and you say, okay, it's this one thing. You go and do this in every business and it saves money. No, you need an analytical eye on this, and there is no piece of machine learning or one overruling piece of software that has got this covered. You need to have to know about all the different nooks and crannies. So it's at the moment this is still owned by humans as a way of looking at it. So we have things like operating system optimizations. So we're straight into the GlobalDots secret sauce actually here, but there are ways of optimizing systems that by patching the kernel, and this one of the vendors we work with is a new one. We're very excited about it, and you can increase your throughput by about 40% and drop your latency by about 30 or 40% as well. So this is looking at, say, a cluster of 10 servers that all do the same job without changing the application at all, but just by optimizing the kernel on the server. You can lose 4 of those, so you can then have it running on exactly the same throughput but on 6 servers instead of 10. And this is huge because it means basically if you've got lazy developers that are writing lazy code and lazy applications that aren't utilizing RAM and CPU properly, you can fix it later on down the line. And this is huge because it means the development time is probably one of the most expensive parts of your business. So if you can have lazy developer code and then fix it later on with a kernel patch, this is gold dust. Next, we've got database selection and query improvements. So the main flavors of database out there, kind of known Oracle, SQL Server, MySQL, and things like that. Well, if you're in AWS and you're using MySQL, this is much cheaper than Oracle. This is very much known already, which is why people used it anyway. So it's very much a sort of de facto standard for a lot of web applications, particularly WordPress and things like that. If you're using that, AWS, for example, have Aurora, which is built by Amazon themselves, and it's compatible with MySQL. So if you're ever looking at an infrastructure diagram and you see a MySQL database, just draw a line through it and put an Aurora database in there. It's about 5 times faster, and it's something like half the price. So total no-brainer when it comes to a database. Like if you're in Amazon and using MySQL, just stop. And then we have query improvements. So sort of back in the old days, people used to be very, very hot on this. Indexing tables for queries to make sure they ran more quickly. And in fact, even when CPU and RAM was really expensive, you wouldn't let somebody write a query on the database who wasn't an SQL developer. You would have to have these things vetted. Well, as CPU and RAM got cheaper, everybody was allowed to write queries, and a Python or a JavaScript or an other developer is not necessarily an SQL expert. So they write, again, kind of lazy or inefficient SQL queries, which can eat up a lot of CPU and RAM. And if you're talking about application performance management, so again, let's talk about a WordPress page. A typical vanilla WordPress page will take about 60 to 100 database calls to build the page. If you're looking at application performance, And once you take away from that vanilla boilerplate WordPress build, you may have 2, maybe 300 calls to the database to create that page. If you have 600 or 700, something like that, then this is not a normal situation. And then if you look into those queries and it's the same query over and over again to get data, you should be caching that query. So caching it at a much higher level. Database at the bottom of the stack is expensive. The web layer is less expensive again. And then the caching layer is the cheapest layer of all. So if you've got something that can be served up out of cache, do that rather than having the endless queries on the database. Programming language and environment specific optimizations. So here we're talking about the out of the box configurations that people often don't change. So thinking about a Java environment, a Java virtual machine, JVM, typically it'll give a memory allocation that isn't tweaked or isn't sized properly. And then the same thing in an environment. So if we're talking about modern environments, Kubernetes environments, Docker environments generally, if you have an application and you've said this microservice needs a gig of RAM and you have 20 of those microservices running, well, actually you've just eaten up 20 gig of RAM for this microservice, and actually maybe that only needed 128 megabytes of RAM, or even less. So you can have all your servers completely full, reporting that all their RAM has been eaten, and it's been eaten by containers that are sitting idle and aren't using their RAM. So there's a lot of kind of out of the box settings that people use, particularly if you come into an organization and they already have a microservice environment running. It's not typical that you go through all the existing microservices and check that the amount of RAM that they've been allocated is correct, and often it's not. And then we have serverless and edge computing. So if you think of the layers of technology like an onion skin, you have the serverless and the edge computing is the outside, and then your virtual private cloud is the next layer in, and then your internal process is the next layer, and then the database and the data storage somewhere in the middle. So the further you go down that onion skin, the more expensive it's getting. Database is the most expensive, and the edge computing and the serverless at the top of the stack is the cheapest. And you're much better off loading things onto the edge. So with AWS, you've got something like Lambda, and every cloud has an edge worker of some description. Cloudflare, they're just called workers. But the onus now is to try and move things as much as possible. So simple calculations or other things that can be done in JavaScript at the edge to move your workload there, and you're going to save money. This is a bit of a double-edged sword actually as well, because the other thing that happens here is if you put things into serverless, you tend to lose visibility. So if you imagine 5 or 6 microservices, or however many, 10, 20, and you only pay for the amount of time they're running, which makes it very cheap, but you sort of lose visibility on how often they're running, how much they're actually costing to run, and how much these microservices are actually talking to each other. So again, this is a bit of GlobalDots secret sauce, and we don't have time to go into all of these things, or else this presentation would be 10 hours long. But we have a technology partner that can actually help you visualize all of your serverless infrastructure, and it can show you how often the calls are happening between the different microservices, how much that's likely to be costing you, and where the bottlenecks are. So, but the leap to serverless comes with its own problems as well, also solvable. So the next part is architecture optimization. So again, we've talked about right sizing before. This is, have you got the right amount of CPU? Have you got the right amount of RAM? There are a lot of tools that will do this out of the box now. So this is becoming more of what used to be like a special feature, if you like, something you would only see in advanced feature maybe of a cost-cutting piece of software. We now see companies like Amazon have stolen that and they're giving it to customers out of the box. But this is the kind of thing that we're seeing, that as people get more wise to it, we're seeing that Amazon then or other cloud providers take it on as a standard and say, you should be doing this to save money. But they only ever tell you the things that will save you money when it's obvious. They won't tell you the things to save money when it's not obvious. Yeah, it's not actually in Amazon's money interest to save you money. They're only saying they want to save you money because they know that these things are becoming common. Batch job optimizations. So we work with a company in Berlin, and it's a photo processing website. So it's artists upload pictures of very nice views and scenic things, and then they sell them on. You can print them on canvases and all this other kind of stuff. Well, the raw images are very expensive to process into the different size and different formats. So they batch job these up, and we utilize spot instances for that, which makes it cheaper. But also spot instances and general computing is cheaper when everyone's asleep. So if you imagine that websites and takeaway sites and all these kind of like mail order sites, while everyone's at work and while everyone's ordering from these websites, they have to scale up. And then nighttime, when nobody's using them, they scale down. And if you can prioritize all your jobs to be running as a batch, it's going to be cheaper that way. But if you can run them on spot instances and also be running them at nighttime when everyone's asleep, you're going to save even more money. Kafka Elasticsearch tweaks. Again, this is kind of using the technology possibly in the wrong way. Elasticsearch is a great tool, and people are kind of starting to lean on it as almost like a database. It's not really what it was designed for. You should be looking at the length of time you're keeping things in an Elasticsearch. So Elasticsearch is tremendously expensive. So the more data you put in there, the longer you keep it, your costs are going to spiral. And if you've done this, out of the box, maybe you've used a CloudFormation or a Terraform template to build it for you. It builds out the resources and builds you a nice cluster. It's very easy. Anyone can do it now. You don't have to be an Elasticsearch expert to build one, but your costs can get really high. So you want to look at tweaking this down, not holding things for months in there, holding them for a couple of weeks, and then archiving the data off, putting them in something like Glacier, slow storage, offline storage generally, and only then replaying the data back into an Elasticsearch cluster if you want to look at it. And then we have networking redesign. So Amazon and other vendors will have multiple availability zones. So let's talk about Frankfurt as an example. You would have Frankfurt A and Frankfurt B, which would all be in it sort of physically around about the same place. And Amazon will always tell you to load balance your cluster or load balance your site or whatever it is you're doing across multiple availability zones. So have some in Frankfurt A and some in Frankfurt B. Now what happens is if you have a database with the data that you require and it only really lives in Frankfurt A and it only fails over to Frankfurt B when Frankfurt A goes wrong, that means that your traffic from Frankfurt web server A to database in A, you're not going to pay extra money on the charge for the data. But the web server in Frankfurt B that needs to get data from the database in Frankfurt A, so A to B, you will pay data charge on that. Even though it's inside Amazon, you still get charged for that. So it's working out where you want to place your resources in your environment that makes sense. Because if you're going, even if you're inside Amazon or inside Google or one of these guys, the data charges, even across their own zones, can really get you. So it's these data centers are already very highly available. So how much extra high availability do you need? If you're a booking website for plane tickets, sure, you need super high availability. But if it's just a marketing site or something like that, possibly you don't need to be spread across multiple zones. And then we've got application acceleration. This is data compression is an obvious one. Compress your data before you store it. You're going to save money. Compress your data before you send it across the internet. It's going to be less to transmit. It's going to cost less. This seems obvious. Lots of people aren't doing it. EBS and S3 read-write optimizations. So the EBS is the kind of your block storage, and this is super high throughput. So you're talking about SSDs here attached to your, solid state drives attached to your server that's performing an action. And if it's again a cluster of servers that are doing some task, let's say it's a WordPress site or another sort of web application, you maybe don't need this super high read write optimization. If you just need high read, then you can possibly put rather than keeping it on a local storage disk, you can put it in S3. And again, you can park S3 off to a content delivery network, so CloudFront or Cloudflare or something like this. So it's thinking about how performant you actually need to have the data and where the best place to store that. Garbage collector optimizations. So memory leaks are something that everybody knows about, or leftover parts of memory from applications, but not a lot of people are doing it. So typically you can set a garbage collector to collect more frequently in order to free up more RAM. And again, when you're doing this across a large number of servers, it really starts to make a difference. Smart infrastructure continuous optimization. So here we're talking if we talk about auto scaling environments, so auto scaling groups, or we're talking about let's say Docker environments that are scaling, or Kubernetes environments that are scaling. If you have two servers that can hold, let's say 50 containers each, so you're running 100 containers, and then you add 101 containers, so you add the 101st container, and in order to host that container, the environment needs to spin up another server to host it. Well, without optimization, you'll get another server that can host 50 containers. So you put one on there and you have headroom for 49 spare, which is not smart. And again, a bit of GlobalDots secret sauce here comes into the equation, because we have vendors that can help you with completely auto scaling environments for Kubernetes or ECS replacements, Docker environment replacements. And this is smart scaling, only adding the headroom that you need and looking at it from an application level, not a server resource level. There's a very fancy word called heterogeneous scaling. And if you want to sound very intelligent in a meeting about that, that's definitely the business bingo word to drop. So here we have some examples. We weren't allowed to share the vendor, unfortunately, with you, but the data is real data from work that we've done with a customer. So we're seeing storage optimization versus the retention policies. And here this is a simple, how long do we actually need to keep the data for? And when it was analyzed, you don't need to keep, unless it's a legal thing and you need to keep it for 7 years. Quite often you really only need to keep data for up to a month, 3 months if you're really paranoid. So yeah, the drop here is obviously where GlobalDots has engaged with the company, and you can see it drops about 70 or 80%. Compute cost to usage increase. So here hello, excuse me. So this is a bit of a difficult one. I'll annotate this because I think it helps to make more sense. The key part here is the GlobalDots engagement. The bottom line is the cost. So initially the cost goes down without loads of increase on the usage. So how utilized things are. And then as we see the usage go up, so the usage is going up quite a lot. And in any other case, if your usage is increasing, your cost would go up. So the more servers you're using, the more it costs. But in this case, because we're fully utilizing the CPU and the RAM of the servers that we're actually paying for, the cost has gone up in this time. The usage has gone up in this time, but the cost has remained relatively flat. So these are the sorts of benefits that we're talking about. This is the one that Francesco talked about before. This is the absolute classic mistake, this is a golden. If you're running public information when you could just be running it internally through your business, I mean, this is the equivalent of if you want to get, if you want to get to a room in your house, you leave the front door, you walk around the whole house, and then you come in the back door. You just wouldn't do it. You walk through the house because it's in your house. This is the same as pumping data around the world when you can just pump it inside. And again, this is a dramatic drop, about 80%, and very, very minor. No great code changes here, just where the data is coming from and going to, and not routing it via the internet. So big savings there. And the last one is migration of Windows to Linux over time. So the overhead of running a Windows operating system, the licensing cost associated with that, it's much lower with a Linux machine. So if you're running vanilla applications, something like Java again, like Java Virtual Machine, you don't have to run that on a Windows machine. You can move that to Linux. Obviously, if you're running IIS or something very Windows based, you're not able to do that, but a lot of times you can. And again, this is around about a 30% reduction in the cost, Linux to Windows. And as I say, with this particular customer, moving them up to about a 90% rate of running Linux over Windows. So it wasn't necessary to run Windows in that environment. And I'll hand back over.
And that, Stephen, is just because of the licensing of Windows machines versus Linux. Let's talk a bit about the methodology by which we GlobalDots help you achieving this. We have two main kinds of customers: the do-it-yourself approach and the do-it-yourself minded, basically, and the more managed minded, right? So what we generally do with customers or prospects out there who are able to configure and run services on their own is, well, as always, the first thing we do, all we do really, is we consult you, right? We try and get deep down into what your pain points are. We really look into it from all angles and end up choosing a tool set fit for the job, right? Second of all, we position GlobalDots secret sauce. Here again, we have a host of third-party technologies which can make your life easier, which can especially automate what can be automated to save you money. So, well, what we do is we position these technologies, we bring you by the hand, and we help you onboard and migrate things to these new technologies. At the end of the day, we try and come up with our tool set of choice, but there are instances where prospects or customers out there ask us for something specific, and then we can do the reverse engineering. We are able to also provide that something, even if it's not part of our portfolio at that point in time. Then we also have the more managed services, managed services minded customers. And here again, we can help. What we do in these cases is we split projects into two phases. The first one has all to do with discovery and initial recommendations. Just like in the slide before, we really look into the bowels of your infrastructure. We look at what can be improved, especially as low-hanging fruits. Remember the famous 80-20 equation? And so, yeah, we build up initial recommendations to start chopping down your costs in the cloud. In our second phase, well, we execute what we promised. So we basically take up what you agreed with us to implement to chop down your cloud costs. And well, like I said, we execute it. We, once again, provide you with recommendations in terms of tool set. We do an even deeper analysis of your application, exactly the point Stephen went through in his slides. And well, last but not least, we also work for you with whichever cloud provider or with whichever provider really to really also fight to lower down your costs. The end result is, well, you're going to save money. Let's say you can save between 30 and 60%. There are notable exceptions, especially in the higher end of savings, but we can hardly provide you with less than 30% savings as part of the results. No fee. Well, that's a pretty self-explanatory point here. if we don't get you what we promised, then there will simply not be a fee for us, right? It's a win-win, if you like. Fully empowered moving forward, well, yes, because at the end of this process with us, you will be much more acknowledged about your environment, toolset, technologies. You will be, you will be much more able to continue on your own, if you like. And finally, yeah, there's finally some more money for your pay rise, and all managers will love you because you're going to be their hero. You're going to be the one who's going to slash down costs by what, 50, 60%. You're going to make up budgets for the DevOps. Finance going to be happy because you don't have to stress them again with asking for a budget, etc. All the good things that you can imagine. Not a big deal. So yeah, as a goodie relating to our cloud cost expertise, I would love you to pay attention to this book written by our CTO Yair Green together with Eli Mansour by AWS. It's a really cool book. So far I'm aware, they're working on a second edition. So please have a look at it. It really is a recipe book for saving you money in the cloud. And it doesn't take me to say that. Just listen to what Jeff Barr says about this book. It's a testament to what we do. I mean, we do this anyways every day. So we also have a written recipe book for this. So just have a peek at it. I guess that's it. Thank you for your time. And let's now see whether we have uh, any questions. There seems to be something. There's one about can we know more about Elasticsearch optimizations? Stephen, do you feel like taking this one?
Sure, yeah. So we talked about Elasticsearch, and yeah, so the optimization we said was looking around keeping data for less time. The other key one here is actually, and I talked about building them from a recipe, so like a Terraform or a CloudFormation. Typically, you're not looking at the compute resources that have been given to that cluster underneath. So you could have under provisioned resource like instances underneath. On top of that, and we didn't touch on it, and again, there's too many topics to go into, but if you, without making any code changes or without making any infrastructure changes at all, you can use reserved instance marketplace. So this is a top tip. And not a lot of people know about it, but people who buy a reserved instance for 1, 2, or 3 years up front, they save enormous amounts of money. But then if for some reason or another the company no longer needs it, the company shut down or whatever, they just want to sell it back to anybody for any price. So it's like secondhand virtual machine basically. And you can buy that from a marketplace for really reduced price and just apply that to your workload. And this is something that doesn't require a developer. It doesn't require anybody with any technical ability really whatsoever. It's just a matter of going onto the marketplace and finding a cheap instance that somebody's already paid for, and then giving them a second-hand price for it. So again, we have some tooling to help you to automate that, which is part of the GlobalDots secret sauce. But yeah, that's another optimization we can have.
Yes, Stephen. How cool is that? I see that there's another question regarding Kubernetes-based environments. Do you address the Kubernetes environments? You want to take that, Stephen?
Sure. Yeah, we absolutely we address Kubernetes environments. So as said before, we look at the memory and the RAM on containers to make sure they're optimized for the environment. But we also have vendors that run completely serverless Kubernetes environments for you, and that run completely on spot instances. So 100% uptime, 100% SLA, but you have somebody else running the whole cluster for you. So if you're familiar with AWS Fargate or AKS or something like that, where somebody else is doing the complete management for you, but you're just launching the containers, imagine that, but basically about 60, 70% cheaper. And again, these are third-party vendors that Amazon cannot tell you about because they, a lot of them, it's not in Amazon's interest to tell you you can run something like this when that's what they do as a business as well.
Yes, we're really short on time here. We're actually supposed to be closing this, but there's a final question and I want to take it. Do you get your cut on top of our cost, or you what else? Well, basically our service is included in your savings. What we look for is part of your savings. And I think that this is a fair proposition, ain't it? That being said, I feel we've come to the end of our Q&A. I hope we raised some interest in you guys and ladies. And if you want to ask for more, please do. You can see our email addresses in here. Please reach out. We can talk about so much more than we talked about in this hour.
And if you made it to the end of the presentation, as an Easter egg for you, we'll share this slide, which is actually, it's from the book. And this is an example of the level that we go to find out where the costs are in an environment. So something you won't get from Amazon, showing all the data it costs from one place to another. It looks like a pretty hectic diagram, but it's this is something that is impossible to find out there in the real world, you know, this level of detail. So that's a little Easter egg present for you if you made it to the end.
We're real nerds when it comes to it, aren't we?
We are the geeks, basically. Yeah.
All right. Well, gents and ladies, thank you for participating to this webinar. Feel free to reach out for more. I wish you all a lovely day ahead.
Thanks, guys. Take care.
Bye, everybody.